All right, so this will be your quick recap or overview of assignment 4, just to help you get the ball rolling when you guys go to actually start this assignment, probably tomorrow, and that's totally fine. So the main idea behind assignment number 4 is we're looking at vectors and how we add these vectors together. It gets pretty easy when we're adding vectors together if they're both in the same direction or both 180 degrees apart from each other. Then we can just simply add and subtract. If they're at angles, which is the whole point of assignment 4, then it's not as easy as adding, subtracting, and I wanted to do an example with you guys so that you could see it. That way you can, kind of feel a little bit more confident with everything that we're going to be doing on that worksheet and on the review that we're going to be going over Thursday and Friday. That way you can be prepped and ready for your test Monday and Tuesday. So when we're talking about this, number one, when combining two or more vectors together, the resulting vector is always referred to literally as the resultant. Let me actually switch over to my brush. It is the resultant. It's what we get from combining two or more of these vectors together. If the vectors are in the same direction, let's say someone walks 4 kilometers to the east and then walks an additional 2 kilometers to the east, right? We add the vectors together. We start at the beginning where the first vector is going to begin. We go to the tip of the first vector, and then that's where the beginning of the tail of the second vector begins, right? The whole tip-to-tail method that the book describes. And if you were to add these two vectors together, then your total distance here is going to be 6 kilometers, right? 6 kilometers to the east. If we had done it the other way, and let's say you walked 4 kilometers east and then 2 kilometers west, you would still draw your 4 kilometer distance first, and then from the tip of that 4 kilometer you would actually then do your 2 kilometers to the west. Technically that should have a negative. When you add those together the way the book describes adding them, it would be a positive 4 kilometers, because that's what you described east as originally. If you ever want to know, should east be positive, right be positive, whatever. Honestly, it doesn't matter as long as you're consistent, but I could give you, if it's specific to the problem, I could give you a frame of reference for it. There's supposed to be a plus sign in between the two. So it's positive 4 plus a negative 2, and then that's how you're going to get your positive 2. The positive meaning it was to the east, to the right. I made that way too long. So there it is. In this particular case, those two vectors worked against each other. So this is what it looks like from the majority of what the textbook supplied, and even the reading note quiz that we did. But these vectors aren't always going to be set up this way. Occasionally, you're going to get vectors that are set up at right angles to one another. We'll do more, significant angles later on. But for the first example, let's say that we walked 4 kilometers to the east and then separately walked 2 kilometers to the north. What we found up top was more or less your total displacement, right? Each time we calculated these things, these were our total displacement from where we started, right? From where you began. But that total displacement, distance from where you started, is really easy to calculate if they're in the same direction. Here, it's not so much. Your total distance in this scenario right here would totally be 6 kilometers, would be the total distance you walked, the total distance you traveled. It's what your GPS would tell you. But your displacement is from where you began compared to where you ended. This displacement is what we're going to call the resultant. The resultant being what we refer to that vector as, and we can calculate exactly how long that is. You might recognize that this easily made a right triangle. So you've basically got a right triangle with a height of 2 and a length of 4, and you're solving for the hypotenuse, right? You're solving for that opposite side. So in all of the problems that we're working on in either assignment 4 or the review guide, this just breaks down to be a squared plus b squared is equal to c squared. C being what you're solving for. In this case, I know right off the top of my head it should be a number greater than 4, because the hypotenuse should always be larger than 4. And then the other thing we could also solve for could be the angle, right? I know on this worksheet I either ask for the angle, and it's always compared from where you start that vector. So it's the angle from where the first vector begins and the resultant meet, right? That small angle that's right there. For each one of the problems that you're going to be working on, that's the angle that I'm interested in. Typically, in order to figure out which vector you should start with, it's as easy as whichever one appears first in the problem. There's not really a right or wrong way to do it. One of the things you should recognize as we do some of this vector addition stuff as the year progresses is that it doesn't matter what order you add them in, you're always going to end up with the same resultant. So if we had done this the other way around and made a right triangle that was different because we started here, went up 2, and then went over 4, notice that your resultant appears in the exact same orientation, and it would be at the exact same sort of angle, right? If you started with the 2, the angle here would be the other of the 2 angles inside that triangle, but really all you've done is flipped that triangle upside down. There's your 2, there's your 4, there's your right angle, and then your resultant, whatever that wound up being. The angle stuff, you can use any of SOHCAHTOA once you get all 3 sides. For this particular problem with the 4 and the 2, because I started only with my opposite and adjacent, personally I'd use tangent, but theoretically if you get hypotenuse correct, you can use any of the 3 and it really doesn't matter. So that's what we're doing with our vectors. Now I used kilometers as my distances here. You'll notice if I flip back over to the worksheet, we have vectors that are measured in miles per hour. That's perfectly fine, right? It's just a unit. So one side of this triangle will be 25. The other side of the triangle will be 350. Down here for my units, I use meters per second. But it's still the exact same idea. These are making triangles, and that's really about it. To answer letter C, you first obviously need to solve for A and B, but you're going to use the same angle in letter C. You're going to use the same angle that you had found in A and B, and from that you're going to be able to answer the last question that was there. But that was really about it. If you're struggling with this one, that's totally fine. This is something we're going to go over for sure on our review day. Thursday and Friday are our review days, and they're specifically set up just to talk about assignment 4 and assignment 5. So if you're stuck on assignment 4, at least give the first half of assignment 5 a shot, because that will be what we're discussing and what I check in on the day that we walk into class. Notice there's more vector stuff at the end, so if you got stumped on it, that's fine. There will be more opportunities to practice, but never hesitate to reach out and ask a question.